So you can see basically what I've done here is I've got this gating here. Basically you've got two inputs and an output, and you've got several clusters of those per this one chip, right? So your output with these, there's a little table that shows you, but there's only one configuration where all of your outputs will go low. And that's where both the inputs are high at the same time. So, you know, what I'm looking for is none of these outputs here being low. They should all be high. And the only way they're going to go low is if both the inputs are high. One of the inputs is coming from the hex inverter here's output. So there's always, as long as I trigger it, which is what I do with my finger, just giving it 60 hertz noise it picks up. So that'll convert that to a relatively 50% square wave coming off the 60 hertz sine. Then you've got that going into inputs here. I've just tied all the second inputs high to the 5-volt rail, so those are always on. And that just means I just need to feed the first inputs my square wave, which should result in an output that swings high and low according to that square wave. So anyway, I mean, you can easily check that with a scope, but I'm going to cut it on, and I'm just going to probe these outputs. So here goes the first output. Well, I have to actually do it while touching this capacitor here. So we got the first output. See, it's working. Then the second output over here, whoops, should be the same thing. If I can, come on, get on there. So there goes the second output. So you see both the outputs are working like it's supposed to. But that's only because I'm using an older chip here. I had to pull this gate chip from my half bridge, and this is another brand new one that fucker just wasn't working. The first set of inputs don't work. So rather than rewiring it using other inputs, I'm just gonna swap the chip out, and I guess this is just garbage. I mean, maybe the other inputs work. So there goes pin 6 output. It's working. But then pin 3 here is just low. It just stays low. It's always low. So what's up with that? You know, is this a shit chip? I don't know. I didn't do anything to it. So, you know, like I say, in that situation, I can either, it's got more than one in and out. You know, it's a multiple output chip, so that's cool. But that's just an example of, you got to check all this crap. Kind of a dirty test rig set up here, but so you can see, here's the circuit laid out. Not very tidy yet, but you can see basically how I'm doing this is going through the GDT here. Now someone sent me a cool looking circuit where basically rather than using a GDT, you're just coming straight off the gate driver into the gates of these MOSFETs. And that situation shared a common ground. Now I didn't really want to do that. You know, the whole point of this was testing to see where they would pop, and I can easily replace these with more fets I've got, but I wanted some type of isolation just to see if that would work, and I wanted to see the difference in outputs and all that kind of stuff. Feedback that it gets from me turning into basically like a huge amplifier to this antenna, to where it picks up the 60 hertz noise around me. It starts up the circuit, the gate drivers get going, and gives just enough of a pulse through here. Any kind of pulse I'm really hoping for that'll go through the secondary, get a little juice flowing, and then as per normal with these circuits, you know, it'll pick up the resonant frequency, feed it back in, and then I've got the circuit going. So I'm going to show that. Cut this on. I'm going to run the drivers from this power supply. Then I've got this one just kind of janky sitting over here. So I'm going to put that it's at 13 volts, totally isolated power here. Then I can just cut it on and it's not going to pull anything. The only time it should pull anything is when it starts feeding back, which again I can do just by touching it. So as expected, this circuit's pulling like 4 amps, over 4 amps at only like 13 volts or so, which is about as per usual. I'm going to see where it cuts out at. So we're at about about 2 volts. Still pulling a couple 100 milliamps. But this guy right here is actually still just barely lit. So 2 volts it still runs. I mean, that's cool. I could pull the tiniest little baby arc off there. Let me see if I can pull something off. I'm do about a little over 3 volts, pulling almost an amp. Still lighting that. Pull the cutout on me. Can I get it back? I'm gonna bring it back up. Yeah, I was able to pull like a tiniest little arcs here around 3 volts. That's cool. At 12 to 16 volts, it pulls what I'm about used to seeing these pull with this design. Except this time, obviously, I've got the gate drivers, and it should be a little better because this is completely isolated. Whereas with the other circuits, there was a lot of problem with interference because you're taking these gates and you're turning them on slightly through a voltage divider, which is more or less referenced off your driver power, and there's a lot of problems that can happen there. First, I need to get it interrupted. Then from there, I'll go on to adding capacitors. Seeing if I can get it dual resonant. Like I say, this is just a random coil. I noticed it didn't work quite the same at all with that primary moved up a little bit, so I don't know. We'll see. So here it is, interrupted, about 15 volts. It's kind of a pain getting this antenna right. I don't think I'm going to stick with the antenna, but yeah, if you don't get it just right, just the way I'm moving my body around here, a little interference, it's kind of messing up. See, it wants to wants to really arc to it though. This is kind of funky. I wanted to see how silly I could get with the primary on this circuit here. It's probably the most ridiculous primary that you'll see on a Tesla coil of this size. But as you might expect, when I cut it on, it's all the way down. Normal operation, I'll get a very low duty spark out here. I mean, I still get something very small over here, right? But I have to draw it out. What I noticed, I actually do hear something funky going on over in this general vicinity. Now, I've got a lot of crap on this table, yeah, and my first thought was, is this thing ringing with something over here? I mean, what's going on? And I basically traced it underneath this table right here. I'm going to hold the phone up near, maybe you can hear it. I'm going to cut the frequency up. Now it's buzzing. Maybe you can hear it better. I'm just touching that, man, I can cut the brightness up. I'm just touching that little screw there. You can see the LED lights up. So, yeah, I hear this buzzing coming, particularly from all the screws on the metal frame around this table. It's really freaking weird. Something about this primary, the shorter primary doesn't do that. It's kind of funky. Alright, so again, confusion. I just went ahead and just did the ridiculous primary like I had on my other setup. When I tried this on my other circuit, the one that looks more dual resonant, that has better output at about 12 volts, what it did was it just barely output something, but the primary, it started doing something funky with the frame of this table. I think it was eddy currents or something. I don't know what was going on, but when I run this coil with this primary, well, it's the same coil actually, but when I run it from this primary off this circuit, for some reason it still works pretty good. So you can see this is what I've got as a primary right now. It's just these damn clip leads that I've put two together. So I've got a pretty wide radius over here. I'm going to cut it on with this primary and then show the output. Whoops. So I'm going to have it at 20 volts. I'll cut the interrupter up. So, yeah, still nothing crazy, but if I cut it all the way up, it's current limited 5 amps, and I get about 15 volts out of it. Before, I think it was hitting about 10 volts or so. So I mean, it's really just not pulling quite as much with the single turn. Oh, just went out there. Hey, I thought something happened, but my little battery just died. Luckily, I got a ton of supply. So anyway, down to 15 volts now. We'll cut it back up. And You know, and it's just funny that I can still kind of pull like decent arc. I mean, 15 volts, not bad for a little SSTC setup. See, the thing there is, you know, it's not, it's the heatsink is warm, and this is a pretty large heatsink, you know, but it's pulling too much for that output. You know, understandable, whatever. See how I can contort this gigantic primary in various ways. Let's add a little loop. Let's add a little exterior loop in the primary. And didn't much care about that. Shouldn't do that. But again, look, the point is, I mean, isn't it kind of amazing it's able to be so far away? And I mean, you're still technically getting, you know, thousands of volts out of here. It's still pulling about 6 amps. Ow. Yeah, but those are more like, you know, your ZVS arcs you might get out of like a flyback driver or something. A ZVS flyback driver. So I got rid of my capacitors. They're actually not identical in value. Well, I think they are identical in value, but I think I think one of these can't handle the frequency as well as the other one. I've gone without the capacitors, using this choke, and now I'm using IRF P460s. And I never did actually pop the 250s I had on there. I did pop one of them, but that was because I was messing around putting capacitors on there while it was running. That wasn't a good idea. Cut it on. Well, let me cut the lights down. So it'll be about 28 volts. So you can see it's above about 45 volts. Instead of getting this straight up discharge, it starts puffing out to the side. And you know, I haven't pushed it higher than that, but that's, you know, that's reminiscent of about what I get from the basic circuit using this coil, about sort of that top load, except this time I've got 460s on here. Alright, so this is basically what I ended up throwing together. The whole circuit board and the whole base of this little coil is much bigger than I wanted it to be, but this thing is going to be my test rig for this circuit for a while. Guy right here, this is my GDT right now. So that is to say, using about, I don't know, 7 or 8 different toroids I had on hand, to where, I've got some that a lot of them were just probably used as chokes, and I've got some that were used in high power applications from like TV boards and stuff like that. I'm not sure which is which. More or less just trying them out, seeing what the inductance was. It kind of turned out the ones which I would have assumed would work best for this application didn't actually work the best. After all that effort, all the testing that I've done with this circuit, all the various things that I've done, I've spent a few days on it. As it turns out, once again, this basic circuit, like you can see right here, is pretty much what matches it. And this is just as simple as just the basic minus the interrupter portion, the TefaTronix style circuits. But as you can see, this is my GDT. By using this random transformer, I'm not quite sure what it was being used for, but you can see the number of turns. You wouldn't assume that this would be a proper gate drive transformer, nor really suitable for a current transformer to get your feedback, but for whatever reason it works. And I've used a few of those. So just look at this right here. I've basically, the way I wire these, I've just got my voltage divider here is just referenced off the positive rail. So technically by running it like this, I'm just going to get a continuous output. And rather than deal with interference and all this other crap, I just PWM this whole circuit externally, which I have several already made for that purpose that I use on various circuits. So I could just throw this together using this coil and get more or less the same output that you're going to see here, just using this and then interrupting it with a PWM. So that's what's crazy. The only thing is, again, I need to stress test this basic circuit to see how much voltage it can take. And I built this around basically the same way that this circuit in here it's almost identical to it. The only difference being that other circuit is also using a GDT that looks sort of like that, except in that other circuit it's a GDT slash feedback transformer. So anyway, I'm gonna cut this on. This guy right here, I've just got this little battery here, which is powering all my control circuitry, and then I've just got this other little external PWM. I haven't actually added one in here yet, so this is just a random PWM I've got that I'm using a MOSFET to close 5 volts to one of the input terminals on my gate chip, I believe. And let's see, I'm running it from this power supply. So you see it's all the way down at like one point. Actually, I'm bring it down to a volt or so. So 1.2 volts or so. I think it's kind of wonking out a little bit. Also, I believe because it's running right now. So you can see it's actually running. It'll still just barely light some stuff. I've got it interrupted. Actually, let's cut it all the way up. So all the way up, it's still pulling slightly over 100 milliamps at 1 volt, but it will just barely light this up. Now, unlike another arrangement I had, I was able to get the slightest little plasma arc at 3 volts, but with this particular setup, using the components I've got, it takes about 5 volts, bringing about 4.9, 5 volts. So I can, so you can see I can start pulling a little plasma flame out there at about 5 volts. But that's drawing it from a little over half an amp to, you know, up to a few amps. So again, it's very characteristic of how this circuit normally runs, except now I've got all this extra shit in here, you know, vastly overcomplicating it compared to what this basic driver does. Which, you know, like I say, I've shown this one before, but that's what's in here, and this one puts out some mean arcs at 30-40 volts. I haven't really pushed it higher than that. But I suppose the benefit with this particular circuit, you know, I have to justify, you know, is it worth all that extra shit? And I guess the way I can justify that is, okay, it's cool, I can run this down to really low voltage. And it acts sort of the same. You know, if I cut it up to 12 volts, nothing super impressive there. It's only pulling a couple amps. It's heavily reliant on my feedback in the GDT as well. Get a little breakout, and I can actually kind of pull it out a little bit. But again, you can see this couple amps, this 2.5 amps is drawn now, gets pulled up to 5 amps just by pushing this bush out. And of course, if you got a supply that can take it, you can pull the hot arcs. So this one, yeah, it wants to pull about 7 amps. This battery is actually starting to struggle a little bit. This drill battery. So kind of similar to a lot of these other ones, unless I get the breakout point just right, I really have to pump it up to about you know, 15-16 volts or so before it'll start breaking out like that. And then even then it's sort of kind of finicky. I can see that has something to do with me throwing the feedback, or, you know, just the capacitance around. Something's going on there. It's not actually the interrupter. Sometimes I can see it is the interrupter. In this case, not really. Yeah, that's funny. I'm not really sure what that's doing at times, but anyway, let's see. Heatsink. This is a fairly beefy heatsink. It does get a little warm. I'm not sure if that's just inherent with this topology, or if it's because my switching sucks, and for whatever reason I'm just getting decent output. Didn't work because the camera cut out, but let me see if I can do that again. But you'll see as I vary the duty cycle, and it pulls less and more power, and that'll in turn decrease or increase the voltage drop on this output here, because at the high voltage you can't push a whole lot. Then you'll see like the arcs kind of propagate upward or around the disc here. 60, 75 volts, I'd say. 75 volts top. Running it at that voltage, man, them things get hot. This heat sink right here is really hot. So I didn't even run it for that long. So I don't know if it's just the fact that I've got really non-ideal switching and I may be overshooting somehow, and that's helping out with these discharges, but it's destructive in the long run, or what really. But you know, like I say, those do get really hot. Would need a fan to run like that in this configuration. But you know, like I say, still get decent output. Same thing as this little bastard right here, though. So I mean, if you compare the two, it's like, which one would I rather build and put together that I could pretty much get the same output from? Now, this is a little cheat. I would need to put a bigger heatsink on here if I really wanted to run it like that. But you know, the whole point is, you know, I could cut this up at, you know, 15 to 30 volts, I'd say, continuous to pull really hot arcs, and it's probably not going to be as destructive on these 250s as it would in this much more complex circuit using the 460s.